Hello, pre-algebra students. This is Chapter 5.1, Rational Numbers. A rational number is any number that can be written as a quotient of two integers. Whole numbers and integers are both part of a set of rational numbers, as we can show in this diagram. So let's move on to identifying rational numbers. Let's show that the integer 7 is rational by writing it as a quotient of two integers. So we could write 7 simply as 7 divided by 1 to show that it is rational. Another example would be -10. How could we write -10 so that it's the quotient of two integers? Well, there are two possibilities. We could write -10 divided by 1 or 10 divided by -1. Each would give us the rational number -10. Another example would be 5 3/4. How could we write 5 3/4 as the quotient of two integers? Well, we'd simply rewrite it as the improper fraction 23/4. And finally, -3 1/2. How could we write that as the quotient of two integers? First, we would rewrite it as an improper fraction, -7/2. Then, to show that it's a quotient of two integers, we could either write -7/2 or 7 divided by -2. Each will give us the correct answer. Now let's discuss terminating versus repeating decimals. Anytime we take a rational number in the form of a divided by b and carry out the division of a by b, the quotient will be either a terminating or a repeating decimal. In a terminating decimal, the division ends because you obtain a final remainder of 0. For example, if we are dividing 10 by 2, we get a terminating decimal because our answer is 5 even. In a repeating decimal, a digit or block of digits in the quotient repeats without end. For example, 1 divided by 3 gives us a repeating decimal of 0.333, and so on. This is an example of a repeating decimal. Let's work a couple of division problems to see some examples of terminating and repeating decimals. So first, let's begin by writing 3/8 as a decimal. So we'll divide 3 by 8. 8 does not go into 3, so we know right away we have to put a decimal point and a 0. And let's see, 8 goes into 33 times. 8 times 3 is 24, giving us a remainder of 6. We need to add a 0 and bring that down. 8 goes into 67 times. 8 times 7 is 56. Giving us a remainder of 4. Let's add another 0 and bring that down. 8 goes into 45 times equally. So here is our terminating decimal, 0.375. Now let's try another. 5 divided by 11. Let's go ahead and work out this division problem. All right, so 11 is going to go into 50, 4 times, 44. 50 minus 44 is 6. Bring down another 0. 11 will go into 65 times. 5 times 11 is 55, giving us a remainder of 5. Add a 0. Once again, we'll go in 4 times. 4 times 11 is 44. 6, you're starting to see a pattern here? I am. We're just going to keep doing this over and over again, where we have 0.45454545. So this is a repeating decimal answer. And we'll write our answer like this: 0.45 with a bar over 45. The bar shows that those digits will repeat. Our answer will be 0.45454545454545, on and on and on and on and on. That is our repeating decimal. Okay, folks, try these 4 problems on your own. Write the fraction or mixed number as a decimal. either as the terminating decimal or the repeating decimal when you complete the division problem. When you come back, we're going to compare some fractions. Let's use what we've learned about fractions and decimals to compare the species of animals found in 2 national parks. Of the 50 mammal species found in Canyonlands National Park, 20 of the species belong to the order Rodentia, so 20 out of 50. Of the 54 mammal species found in the Badlands National Park, so 54, 24 belong to Rodentia. In which park is the fraction of mammal species belonging to Rodentia greater? Okay, so we're going to write a fraction for each park. We've actually already done that. 20 out of 50 for Canyonlands and 24 out of 54 for Badlands. Now we're going to solve these by placing them into fraction form. 20 divided by 50 is equivalent to 40 over 100, or 0.4, 4/10. Let's do the same for 24 divided by 54. Okay, so 24 divided by 54 is going to be a little bit more complicated, right? Let's try this. We have 240 with our decimal point in there by 54. 54 is going to go into 240 4 times. 4 times 4 is 16. Carry the 1. That gives us 216. So a remainder of, let's see, what do we have here? 10 minus 6 is 4. 3 minus 1 is 2. 24. Oh, look here, guys. It's going to be 240, 240, 240. So 0.44. All right. So in Badlands, it's 0.4 repetant, or repeating. Put the bar over the top. So now we're going to compare our decimals. Which is greater? 0.40 or 0.44? It'll be 0.44, correct? So the fraction that is larger, 24/54, is greater than 20/50, because 0.44 repeating is larger than 0.40. Okay, let's move on to the next idea. We've learned to convert fractions into decimals. Now let's go the other direction and write terminating decimals as fractions. Here's an example. 0.7. In this example, 7 is in the tenths place, so we know that we have 7/10. We simply rewrite it in fraction form as 7 over 10. Another example would be negative 3.05. 3 is a whole number, so we'll leave it as that. And 5 is in the hundredths place, so we'll place 5 over 100. So we'll simplify our fraction to 3 and 1/20, because both 5 and 100 are divisible by 5. There we go. It's pretty easy with a terminating fraction, but a little bit more complex when we're writing a repeating decimal as a fraction. Let's try a couple examples there. Let's write the repeating decimal 0.93 repetant as a fraction. The way that we'll do that is we'll let x equal 0.93 repeating. Because 0.93 has 2 repeating digits, we're going to multiply each side of x equals 0.93 repeating by 100. Okay, so we're going to take each side and multiply by 100. Sorry, I should have given myself a little bit more room there. So we now have 100x equals 93.93 repeating, right? Because we know 0.93 repetant is 0.9393939393. So if we multiply by 100 and move our decimal place 2 places to the right, there's a 0.93 after that. And then on and on and on and on. So it becomes 93.93 repeating. Now, we want to simplify by getting rid of that 0.93 repetant. And the way we do that is that we subtract this from our new answer. So now we're going to subtract x equals 0.93 repeating from this equation. And that's going to give us 99x's equals 93. See how that works? Now we solve for x by dividing by 99. X equals 93/99, which can be simplified because each of these numbers are divisible by 3 into 31/33. So 0.93 repetent is equal to 31/33. Now try this on your own. Write the terminating decimal, 0.3, as a fraction, and then write the repeating decimal, 0.3 repetent, as a fraction. Good luck! And here's our last idea for this lesson. We're going to order rational numbers using a number line. Here's our set. -5/4, -0.2, 4.31, -3, 5/2, and -13/3. So we're going to order these from least to greatest by graphing our numbers on the number line. All right, let's go ahead and get started with that. We'll put 0 here, and it looks like we need to go to probably about 5 on each side. Okay. -1, -2, -3, -4, -5. All right, let's start graphing these numbers. -5/4 is going to be just over 1 1. It'll be 1 1/4 to be exact. So here's -5/4. -0.2 is 2/10. It's going to fall right here. 4.31 will be right around here. I'm just going to guesstimate here. -3, that one's easy, right here. 5/2 is the same as 3.5, or excuse me, 2.5. That'll be right here. And finally, we had -13/3, which is, let's see, 4 1/3, right? So -4 1/3, right around here. Okay, now we simply order these numbers. -13/3, -3. I'm just working my way from left to right on my number line. -5/4, -0.2, 5/2, and 4.31. Ta-da! Finished. We've ordered our rational numbers from least to greatest. And that brings us to the end of section 5.1. When I see you tomorrow, we'll do more practice with rational numbers. See you then.